Hello friends, welcome back to the spectroscopy. In the first part, we have studied the meaning of spectroscopy and electromagnetic spectrum. In electromagnetic spectrum, different electromagnetic radiations, they are arranged according to their wavelength, frequency and energy. Therefore, in this part, we will discuss the nature of electromagnetic radiation and the characteristics of electromagnetic radiation, that is wavelength, frequency, wave number, amplitude, velocity, and energy. Each and every electromagnetic radiation is having this type of characteristics, and depending upon the wavelength, frequency, and energy, they affect on the compound or molecule differently and causes different changes in the molecule. Therefore, we have to study the nature of electromagnetic radiation, which is crucial in case of spectroscopy. So before starting with the nature of electromagnetic radiation, I will show you one video that will clarify your concept regarding electromagnetic radiation or electromagnetic wave. Electromagnetic radiation, it is having a dual nature. It exhibits the properties of waves, also properties of particles. Here we will see the wave nature of the electromagnetic radiation. It is the wave, and it is composed of two fields. One is electric field and another is magnetic field. Blue color indicates electric field, whereas red color indicates magnetic field. These two fields, they are oscillating perpendicular to the direction of propagation as well as perpendicular to each other. So the electromagnetic radiation, it is composed of two fields which are perpendicular to the direction of propagation and perpendicular to each other. This is how the electromagnetic radiation propagates in space. Now we will study the characteristics of electromagnetic radiation. From the video, it is clear that the electromagnetic radiation or electromagnetic wave, it is composed of two field, that is electric field and magnetic field. But for our convenience and for understanding, I have taken here only one field, that is electric field, and this electric field, it is oscillating in the x direction and it is perpendicular to the x-axis. Now the first characteristic is a wavelength. The wavelength is nothing but the distance between two identical points on a successive crest or a cleft. So this is the wave, and this wave, it is having two part. One part is a crest and another part is the cleft. So this is the crest and this one, it is the cleft. Now just we have to consider two successive crest or a cleft. This is the first crest and this is the second. These are the successive crest, and in the definition there is a two identical point. These type of words are there. Therefore we have to consider identical points on a successive crest. Suppose this is the point and this is the second point. Now these points are identical. Why they are identical? Because they are having a same distance from the x-axis. So the identical point indicate the similar distance from the x-axis. Now the distance between these 2 points, it is nothing but the wavelength. So if I calculate the distance between these 2 points, it is called as a wavelength of that wave. And this wavelength, it is denoted by a symbol that is called as a lambda. This wavelength, it is having a different unit in a different spectroscopic technique. In ultraviolet spectroscopy, angstrom and nanometer is used, where 1 angstrom, it is equal to 10 raised to minus 8 meter, and 1 nanometer is equal to 10 raised to minus 9 meter. Whereas in case of visible spectroscopy, micrometer is used. 1 micrometer is equal to 10 raised to minus 6 meter. And in case of NMR spectroscopy, when wavelength is used, it is in a meter. So this is about the wavelength. Then the second characteristic is the frequency. Now, to understand the exact meaning of the frequency, we have to consider a complete cycle. Now the complete cycle, it is nothing but one crest plus one cleft. So the complete cycle, it is composed of one crest and one cleft. So from this point up to this point, it is the complete cycle. Now, when if I choose here a point and if I calculate the number of complete cycle passing through this point per second, so in a unit time, the number of complete cycle that are passing through this point, when we calculate, then the amount that will be a frequency of that wave. So the frequency is nothing but the number of complete cycles passing through a point per second. Then this frequency, it is denoted by the symbol nu, and it is having a unit cycle per second, or it is also called as a hertz. Then megahertz also used. 1 megahertz is equal to 10 raised to 6 hertz, and it is also equal to the 10 raised to 6 cycle per second. Now the third characteristic is a wave number. It is simple one. It is nothing but the reciprocal of the wavelength. So the definition of this wave number is a number of complete cycles or wavelength per centimeter distance. Suppose 1 centimeter distance is there, and a wave, it is having a complete cycles, that is 10 cycles. So in 1 centimeter, if the wave is having 10 cycles, then the wave number of that wave is a 10, and the unit for this wave number, it is the centimeter inverse, and which is called as a Kaiser, and it is denoted by the symbol a nu bar, and it is nothing but wave number is equal to 1 divided by a lambda. The next characteristic is velocity. Velocity is nothing but the distance traveled by any wave in a unit time. It is denoted by the symbol, that is capital C, and it is having a unit meter per second or a centimeter per second. When we consider the velocity of light, it is found to be c is equal to 3 into 10 raised to 8 meter per second. The velocity depends upon the medium through which electromagnetic radiation passing. So the velocity is nothing but the distance traveled by a wave in a unit time. Suppose one wave is there and it is traveling a distance a 10 meter in a 1 second, then the velocity of that wave is 10 meter per second. The next characteristic of the wave is amplitude, and the amplitude, it is defined as a maximum displacement of the wave from the x-axis. This is the x-axis, and this is the crest, and this is the cleft. Now at this point, this crest, it is displaced and it is having a maximum value, and at this point, this cleft, it is displaced and it is having a maximum value. This maximum displacement, it is called as, suppose this is the A and this is also a, this A is nothing but the amplitude of that wave. The last characteristic of the electromagnetic radiation, it is the energy. Each and every electromagnetic radiation carries energy in the form of packets, and it is called as a quanta or a photon. It is a discrete amount of energy. This energy it is given by E is equal to H and nu, where H is equal to the Planck constant and nu is equal to the frequency. So the energy is directly proportional to the frequency. Now we will see the relation between the wavelength and energy, wavelength and frequency and energy. The first relation is between frequency and wavelength. Here frequency is nothing but the velocity divided by the wavelength. So nu is equal to c divided by lambda. We know that c is equal to 3 into 10 raised to 8 meter per second. Therefore, nu is equal to constant because this is the velocity of light which is having this much value divided by a lambda, and this indicate frequency is inversely proportional to the wavelength. Then the second relation is energy and wavelength. Here energy is equal to Planck constant into the frequency. Now instead of frequency we will write c divided by lambda. Therefore it becomes a Planck constant into the velocity of light. The whole value, that is h into c, it become constant and it is divided by lambda. This indicate energy is inversely proportional to the wavelength. Now from this equation it is clear that energy is directly proportional to the frequency. Now another relation, we know that a wave number is equal to the 1 divided by lambda, that is reciprocal of wavelength. Putting the value of 1 divided by lambda into this equation, we get, I will write once again, E is equal to h nu, which is equal to hc divided by lambda, and it becomes 1 divided by lambda is equal to the wave number. Therefore hc wave number, that is nu bar, it indicates that energy is directly proportional to the wave number. So from this discussion it is clear that we get energy directly proportional to the wave number, energy directly proportional to the frequency, energy inversely proportional to the wavelength, and frequency, that is nu, is inversely proportional to the wavelength. So these are the important relation in case of spectroscopy. From this relation it is clear that energy increases, wave number, frequency increases, whereas the wavelength decreases. Frequency increases, wavelength decreases. So by using these relations, one can calculate or one can solve the problems on a spectroscopy. So this is all about the spectroscopy. In the next video, we will see ultraviolet spectroscopy.